Good afternoon everyone, I am Mr. Rich. Thank you for joining me for this video where we are looking here at a part 2. We're applying differentials to the concepts of trigonometric functions to make good trigonometric approximations. If you've watched the previous video, then you know what this means. Your approximated value, your end result will be equal to a y plus a dy. You know your differentials here are dx and dy, but you have to determine these two to get to your approximated value. We can do this and learn best using two examples. Of course, you can do everything here with a calculator, but it would take the fun out of it because you want to use derivatives to come up with your approximations, and it's an excellent learning exercise. My first question can be cosine of 59 degrees. How can I use derivatives to determine this value? You can, and I'll show you. I know there's a certain right triangle which comes close to that, and it's a 60, 30, 90. We're not drawing anything to scale, but this is my right triangle. Here's 30, here's 60, here's 90. This is a root 3, this here is a 2 and a 1. You know cosine 59. The value should be close to a cosine 60. What's cosine 60? Look here on your triangle. You know it's equal to adjacent hypotenuse. It's a 1 over 2, which you know to be 0.50. And you know our value, cosine 59, should come close to that. You need to determine what a y is, what a dy is, what a dx is, what an x is to come to your approximated value. We can easily determine this. How do I know what my x is? Your x is your standard value you're using to help you through your computation, which is this. Therefore, this right here is my x, and I've determined that. What is my y? Your y is your test value running through the function, and what is the output of that function? Remember, y is equal to f of x. F of x represents my output. Cosine of 59 should be equal to cosine of 60, which is equal to 0.5. This right here is my output. It's equal to my function, and this right here is my y value. So I already know what my y is. It's 1 over 2 or 0.5. We've knocked these two items out. We just have to worry about dy and dx, and I'll show you how to determine that. What is your function here? Y is equal to a certain cosine x. What's the derivative of this function? Dy or dx is equal to minus sine x. What's dy? Push the dx on the other side. It's equal to minus sine x dx. Now everything is coming into play. I know what my x is. It's 60, and I can easily determine it. But let's worry about dx. I have a certain angle here, 59. I have a certain angle here, 60. This is one x value. This is another x value. Here's my standard value. This is the value I'm interested in. I'm looking backwards. My delta x, which is equal to my dx, the differential, is equal to here what? It's equal to a minus 1. That's your dx. But look, this is minus 1 degrees. Your value here are in degrees. When you're looking at differentials here for trigonometric computations, you must convert the dx, which is in degrees, into radians, and you have to do that. I have a minus 1 degree dx. I multiplied by pi over 180, and I'm looking here at a dx which is a minus pi over 180, and I know my dx. My dx is minus pi over 180 radians, and I'll put it over here. Minus pi over 180, that's my dx. Now let's focus here on dy, and it's easy because you already know the derivative. Your derivative is minus sine x, and you bring in your dx. What's minus sine x? My dy is equal to minus sine of x, which is 60, times my this value, which is in radians, minus pi over 180. What's minus sine of 60 used here? I have an opposite over hypotenuse, which is a minus root 3 over 2 times a minus pi over 180, which is equal to a root 3 pi over 360. This right here is equal to my dy, and it's solved. I have here a y value and I have a dy value. I'll add them up. Now how do we take this to completion? I've determined my dy. These minuses cancelled out. They became a positive. I know my y, which is my output, f of x, output 0.5. I know my approximated value is equal to y plus dy, which is a 0.5 plus root 3 pi over 360. You run this on your calculator, you'll have your approximated value for cosine 59. Let's do it. Keep your calculator on DEG mode. You have a square root of a 3 times pi divided by 360 plus 0.5. I'm coming here with a 0.5151, and I'll keep that as my answer, and it should be good. 0.5151. This is equal to cosine 59. Now let's bring out our calculator and check the accuracy of it. 59 cosine 0.51 0.50. I'm differing here only by the fourth digit. I'm happy with this output and we're good. Remember, approximated value is equal to y plus dy. You still need to know what your x is, you need to know what your y is, you need to know your dy and your dx. These are the items you need to know. X is your standard value, which was 60. Y is the output of that standard value running through your function, 0.5. dy is the result of your derivative. Dx is the result of your increment, which you know to be minus 1. Because from here, 60 to 59 is a minus 1, but you convert that into radians by doing a pi over 180 computation. You multiply a degree by pi over 180 to convert it into a radian, and this question is done. 0.5151 is close enough to cosine 59 degrees. In this second and last question, we close out our video because this is good enough practice. Tan of 46, how can we determine what this is? Think back to your trigonometric ratio triangles. You have a 45, 45 and a 90, 1, 1 and a root 2. When I do tan of 45, I know it's equal to 1. Tan of 46 is reasonably close to tan of 45, which you know to be equal to a 1. Your end result here should be close to a 1, not exactly 1, but it should be close to it. I need to know what my x, what my y, what my dy and what my dx are. My x is my standard value here, 45. My y is the function using that standard value, which is tan of 45, which is equal to 1. This right here is my y value. So now all I have to do is determine my dy and a dx. Dx is easy. Think about your incremental change. I have a 46, I have a 45. Here's my one x value, here's my other. I'm coming back over here, I'm doing a plus 1. My delta x here, which is equal to my dx, is equal to a 1. But you have to convert this into a radian. You know you multiply this by pi over 180, which is equal to a pi over 180. That's your dx. My dx here is equal to pi over 180 radians. And that part is done. Let's think about our dy. dy is coming from your derivative of your function. Your function is tan x. If y is equal to tan x, derivative dy over dx is equal to secant square x. Push the dx on the other side. dy is equal to secant square x dx. I have two separate components. I have my dx, which is pi over 180. I know my secant square x because I know what my x is. My x over here is 45. Let's bring it through. You know when you're thinking about 45 triangles, degree triangles, cosine of 45 is equal to 1 over root 2. But when you're doing secant of 45, it's the reciprocal of it. It's a root 2. I'm bringing a root 2 over here because you can easily use your trigonometric ratios from here. Secant of this angle is a root 2. The secant square of that would be a root 2 square, which is a 2. So my dy is equal to secant square x with the 45 coming here and a dx, which I already have. I have here a root 2 square times my dx, which is in radians, pi over 180. And you know you have a 2 pi over 180. This right here is equal to dy. You can simplify it, make it pi over 90, but I'll keep it as is. Come to this formula right here, y plus dy. I know my y is equal to 1. I have a 1 plus 2 pi over 180. All you have to do is compute this and you'll get your approximated value, and you can keep your calculator on your basic mode. I'll have here 2 pi, 2 times pi divided by 180 plus 1. I'm getting here 1.0349. This is equal to tan of 46 degrees using differentials. So this is the value I get here using my approximations, but how off is it from the actual value? If I take 46 tan and I do it, I have 1.0355. It's slightly larger than this. My approximate value is coming slightly smaller than the value on the calculator. But how much smaller is it? Let's look here at the value that I've gotten, 1.0349. I'll minus that from 46 tan, which is the calculator value, divided by 46 tan, the calculator value, multiplied by 100. I'm looking here at minus 0.061 percentage off. That's how much my marginal percentage of error is, minus 0.061%. That's how off I am, which is good. Anything up to 5% is very good or acceptable, but minus 0.061 percentage off is very good. I'm less than the true value, but I'm very good in terms of the acceptable range where I'm supposed to be falling in. So this value here is perfect. Again, we use the concept of differentials, dy dx, and here this is the formula y plus dy to give you your approximated value, and it brings us to the end of this video.